Andy, thanks very much for that. And before I introduce our keynotes, I wanted to also thank the Alliance for bringing us all together today. The Alliance has been a great asset to the Southern California innovation community. As someone who's worked with startup companies here for almost 25 years, it's fantastic to have people creating connections and bringing us all together. So thank you to the entire Alliance team for all the work that you do. I have the privilege today not only to represent my firm KPPB, but also to introduce to you two incredible keynote speakers. I think it's fantastic that we have the opportunity to invite people as accomplished as our keynotes to come share their experiences in the field of public policy and fostering innovation in large tech. And as they framed it, this is really an opportunity for big tech to come and talk to the future of tech about how they're viewing the role that AI is going to play in the new ecosystems that are emerging. So without any further ado, I have the pleasure to first introduce Keith Strier. He is the Vice President of Worldwide AI Initiatives at NVIDIA. He has responsibility for NVIDIA's strategic and commercial engagements with foreign governments, including the government of Australia, which I was very curious to see as someone who grew up in Australia. He also leads the company's AI Nations Initiative, facilitating public-private partnerships that help governments build sovereign AI capabilities to drive economic growth. Keith came to this role through 30 years of global leadership, 30 years of global experience, having previously served as the first global AI leader for EY and the first global chief digital officer at Deloitte. The number of governmental research committees that he serves on is so lengthy, I'm not going to go through all of them, but he's consulting with the OECD and governments and think tanks around the world on issues of AI and public policy. So it's a real privilege for us all that Keith is here to speak with us today. So Keith, if I can welcome you up, thank you very much.
All right, I think, can I turn this away since I got my little lavalier? Great. All right. Hey, great to see everybody. And all right, and Andy, thanks for staying on top of me because you've been pinging me for like 2 years to come out and do this. I'm really glad that I did. I live in Orange County, so it's not too far. It took about 2 hours to get here, but it was a straight shot. There was no traffic. All right, so yeah, let's get into it. So, you would expect if you're going to invite someone from NVIDIA here, I'm going to talk to you through the lens of computing because that's kind of, that's the world I swim in every single day. And it's interesting, if I go back in my career, and you were just referencing my career in consulting, I spent 17 years in the Big Four. And in the last 5, I was at Ernst & Young, EY, and I was the founding global head of AI for EY. And, for the most part, my experience in that time, which was basically 2016, 2017, 2018, AI was really surging in terms of its relevancy. It was hitting the mainstream. In fact, the first national AI strategy was published by Canada in June of 2017. Even before that, the World Economic Forum kind of pegged AI as this transformational fourth industrial nation, fourth industry sort of enabler and that kind of thing. So there was a real awareness emerging. But even going forward for the next few years, while AI kind of hit the radar, became a mainstream topic, definitely started to drive both policy and investment. At the same time, computing was still far off the screen. The vast majority of people in business and in government just weren't thinking computing was all that interesting or all that important. And when NVIDIA approached me in 2019 and said, we'd like you to come over from EY, help us lead this initiative called AI Nations, I had sort of validated that point that we were obviously AI was taking off for sure. Still early days, but taking off. but nobody was thinking about computing. It was just, and it seems so logical to me. You can't really have AI without computing. So if AI is going to take off, computing is going to follow it. In fact, it may even surge ahead of it. You just can't have one without the other. But so I saw that as a great opportunity to kind of be part of that. And I was really glad that the door opened. In 2019, Dave just talked about AI. Well, Andy talked about it happening quickly. So, obviously, the best way to think about it is sort of like pre-ChatGPT and post-ChatGPT. ChatGPT came out in November of 2022. And before that, there was generative AI. Before that, there were large language models. That wasn't a new field by any stretch. But, something magical happened in November of 22 when they took this really complex technology, wrapped a really simple UI on top of it, and put it on the web. And it just blasted the doors off of everyone's imaginations. And within the period of 60 days, 100 million people had started using it, which was the fastest adopted technology in the history of mankind. And so that was the kind of the game changer. And so it was a really interesting sort of diffusion of innovation kind of event. What happened after then, right, in the last 18 months, essentially, is the world has gone from awareness to alarm, essentially. The alarm part, there's good and bad parts of that. The one part of the alarm is, holy cow, this is real, this is happening, we need to get on board. And the other part of the alarm is, wow, this is real, this is happening, what about all the risks? So there's a couple of different sort of narratives happening at the same time. But it did accelerate things dramatically across the world. And one of the questions, and one of the things that changed was the very sort of purpose of a computer, right? These are your classic sort of WikiLeaks definitions, right? What is a computer? What does a computer do? It stores and retrieves information. It carries out a sequence of logical operations. These are really boring engineering type answers. But this is the historic answer to that. This is no longer the case. Computers are now manufacturers of intelligence, right? This is what they are. Data comes in, tokens come out the other side. Right? And what's in between is an AI factory. It's the new factory of the future. It's the manufacturing base, the new means of production, right? And so that data comes in, and that data is then converted into all different kinds of intelligence, right? It could be new content, it could be insight, it could be a conversation, it could be a million different things. But it's not just a sequence of tasks. Right, and if you've heard of the word robot, right? The word robot is the Latin root of robot is work, right? And essentially, what a robot does, it just does work for you. It executes a command, an order. So all robots up until recently were dumb robots. They followed orders, they followed commands, and they had a series of orders built into them, right? If this, then that, right? The convergence of robots and AI creates this new generation of intelligent machines. Right, and so we're just entering a new paradigm. So we are on the cusp also of humanoid robotics, right? That's another thing that's happening. So manufacturing intelligence is the new paradigm. Now, in order for that paradigm to happen, you also have to understand what's happening under the hood, right? All the computers that have been available to us up until the 90s were all based on CPUs or this certain kind of classical or Van Neumann computing model. That still exists. It's not going away. We're always going to need CPUs. But what NVIDIA and Jensen Huang and his co-founders did is they invented this thing called the GPU, a dedicated processor to accelerate certain workloads. Despite what people think, it wasn't developed just for gaming or just for graphics. That was really just the first workload. That was the first problem they figured, hey, here's a really great problem to solve. And there's a ready market for it, so why don't we focus on that? But what they were building back in the mid-90s and what now exists today as one of the most successful companies in the history of the world is they built a new kind of computer based on the GPU. And that chip goes inside of a box. That box is called a server. That server gets racked up, along many other servers, hence the sequence there, right? And then you make those racks available through the cloud. Now, just to give you a sense of how powerful what we're talking about, right? And I'm not going to have engineering level conversations because I'm not an engineer and I won't pretend to be one. But here's one of my top engineers the other day was giving us just a little bit a great anecdote. This chip, the Blackwell chip, which is our newest architecture, just announced a few months ago, and it's coming available later this year. It weighs a few ounces. It sits in the palm of your hand. It's just the middle piece, right? That chip. That chip has a few ounces, we'll call it 2 ounces, has as much power computationally as the Titan supercomputer from 12 years ago, which weighed 500,000 pounds, was the size of basically this room, a tennis court, and cost $100 million. Now it sits in the palm of your hand and weighs 2 ounces and probably costs about 500,000. So that's the kind of innovation we're talking about. This is exponential growth. This is 1 million times order of magnitude in terms of performance improvement in 10 years. And they can't even imagine where we'll be 10 years from now, right? So that box has 8 of those chips, which means it has the equivalent of 8 Titan supercomputers, which means that one single server 10 years ago would cost $1 billion. A single server. That would be the most expensive box in the world, $1 billion, right? Then you take those and you rack up 20 or 40 of them, $100 billion, whatever, tens of billions of dollars, right? But that right there, that costs 25 million, 30 million. And that is 1,000 times more powerful than what existed 10 years ago. So the order of magnitude of speed and power. Now, why does it matter? Without getting any deeper in the hardware, software stack, it's just obviously this changes the nature of computing, which changes the art of the possible, which then enables you as entrepreneurs to think much bigger, much bolder, do things you never thought before. But you also have to think about scarcity. And this is really important because a couple of things changed in the last year that were less obvious and that were not in the press as much. So you've all heard of AI chips being scarce, and obviously people are competing for to get the chips and to buy the chips and all that. But that's not the only thing that's scarce, right? Those chips have to go inside of specialized data centers. Those are scarce too. I was in a small country in Southeast Asia just 2 weeks ago, and they have 32 data centers in that country, and only 2 of them can handle AI. So 30 of the 32 data centers are not able to handle what's coming in the economy. That means that the vast majority, right, more than 90% of the data centers are useless in that country. That's a pretty big problem. And I don't know if that 90% is true for everywhere in the world, but you do have a reckoning that as these chips inside these servers, inside these computers, the amount of cooling and power they require to meet the needs and the demands, whether it's a biomedical AI venture or it's a consumer AI venture or it's a government, whatever it is, there's not enough data centers today. And so there's a big wave of upgrades and build-outs coming, and that's good. That generates business for the wider ecosystem. And of course, that also comes into the next issue, which is the scarcity of electricity, right? And the absolute requirement that you think sustainability through the entire data center, not just are there solar panels on the roof, but the entire computer from end to end, the entire data center as a computer has to be designed and operated sustainably. So you have to think beyond green energy, you really need a green data center and you need green AI. And so you need sort of all in, the scarcity issue is important. Now here's why it's important to you as an entrepreneur, is that if you're serious about AI, and no, not everyone here is going all in on AI, but to the extent that AI is a part of your future, a part of your model, if you are not planning and budgeting and raising capital for AI computing, you will not exist. And I'm telling you this because we see this, happening on a weekly basis. We have private equity funds and venture capitalists that are doing 500 million, billion, multi-billion-dollar rounds just for computing. That never happened before last year. That was brand new in 2023. We always work with startups, but we never had startups come in the door and say, I have $1 billion to buy computing. It just never happened before 2023. This is a completely new time now. And now, if you're serious about AI, and particularly large language models, and you don't have access to 20, 30, 40,000 GPUs, then you just cannot compete on a global scale. You just can't. So that definitely creates a haves and have-nots, but it is the new reality, and so these scarcities do matter. What's happening also in tandem, and this is a lot to do with the job that I do at NVIDIA, going around the world, engaging with governments and advising them on their strategy, is that this has gone from being a scientific endeavor to being a policy imperative on a global scale, right? I mean, it has geopolitical consequences all over the place, right? And so but the other thing that's interesting is there's really, even in the wealthiest countries in the world, like the US, there's a scarcity. So here you have, this is a screenshot. The NAIRR, or NAIR, is a very important initiative that took several years to percolate, that's now been passed, which is basically trying to make it easier for researchers and scientists within the US to get access to both the models and the computing they need to advance their research. You would think, well, how's that a problem? I mean, this is the United States. We're really wealthy, but even within the United States, there's not enough computing, not enough access to support all the researchers and all the science. It's a gating factor. And it is in every country in the world, and the US is doing what it can. Just 3-4 days ago, just to give you an example further of just how big a deal this needs to be for startups, CoreWeave is a company that most people have never heard of. I mean, most of you probably, if not any of you, have heard of CoreWeave, but they just finished the second largest private equity round in history for one purpose, to buy computing. This was on Friday, okay? So and their sole purpose for living is to create a specialized cloud to support other AI ventures and companies and even people like Microsoft. So this is really happening at an unbelievable scale. And again, it's also very much a policy issue. It's not just about business. And there's implications for not just economic policy, but for healthcare policy and the future of sort of public health wellness in every country. It comes up a lot in conversations. But we are in this era of AI nationalism, where countries now see this as really one of the key determinants in the future of their economy. Right? It's not just, oh yeah, and we have computing, or we have the cloud, or we're accessing AI. This is like top 3. And at the head of state level, at the crown prince level, at the king level, across the world in different nations based on their politics, but pretty much everybody has universally agrees. And in some countries, healthcare in particular is one of the top considerations as well. Like the reason they're prioritizing it, the reason they're investing in it is because of concerns about population health and wellness, about the rise of diabetes, for example, in one country, or fear over future COVID issues. And so just this broad idea of AI nationalism actually boils down in some cases to a specific industry focus, and in some cases it's energy, in some cases it's healthcare. But this has interesting implications for you as a startup as to where you might want to sort of focus in terms of business development. So, AI is a big term. It isn't one thing. It's a constellation of things. And obviously, in that constellation, the brightest star is really generative AI, right? And that's the thing that we're all talking about. That's the thing that exploded on the scene. And, generative AI, we most associate it, in terms of the ChatGPT conversation with something that we can talk to, a chat bot, a term that I really don't like, but, it stuck. But that completely sort of, it's a myopic understanding of the potential, and particularly for you guys, you may have, look, there are healthcare versions of this that relate to conversation or summarizing texts like patient summaries and EMRs and that kind of thing. But some of the most exciting applications of large language models have nothing to do with text. It has to do with the language of life, right? It's about training these models in biology and chemistry and genomics and proteomics. And, and as you start to see how this technology is being applied to any kind of language, because ACTG is a language, right? And to discover protein, to unravel the mysteries of protein folding, to actually develop completely new materials. So, we're seeing this just Cambrian level explosion of innovation across the world. Where this same technology that people worried about students cheating at school, and I have 3 teenagers, and so I look at that issue. So there's sort of how are people using these chatbots in their daily lives? To the same technology is going to reinvent medicine. It's going to reinvent drug discovery. It's going to reinvent material sciences. It's going to reinvent the earth sciences and geological sciences, climate science. So many of the scientific domains are going to use this technology to significantly boost discovery and advancement. It's really, really exciting. And of course, none of that is possible without, convergence of disciplines like computer science and others. Essentially, every field becomes computational in nature, right? And I sit on the advisory board at Oxford, one of the, arguably the #1 university in the world. And, even at such a top university, they argue and they worry about how to get enough compute to their researchers in all of their departments, from economics to anthropology to ecology. It's not just it's not just the computer science department anymore. It's all the departments. Everybody needs access to large-scale computing, both not only to develop models, but to run simulations and these other things. And it is, again, a new reality. And then when you combine AI on top of these large computers, it takes things to a whole new level. So anyway, a lot going on in that field. And just to wrap it up, NVIDIA is, a really unique company. Most people just think about the chips, but the chips are at the bottom of the stack. So yes, we do design amazing chips. We don't manufacture them, other people do. But we have these incredible chips. But it's the whole slide is the reason why NVIDIA is worth $2.4 trillion. It's not because of the two circles in the bottom, right? And that's what people don't understand. What's interesting about this slide is this is not a new slide. I mean, Jensen's been showing a version of the slide for years, but people weren't paying attention. You know, that's the honest truth of it. But the story, the narrative has not changed. You know, NVIDIA is not a chip company. It's an accelerated computing platform company. That platform is built on chips, but includes hardware and software and domain capabilities and an incredible library of very domain-specific software, which is at the top, that brings that hardware to life. And that's just not something everyone understands, but that is the roadmap that the journey NVIDIA has been on for 35 years. And so it's not really an overnight success. But you know, in the last 5 to 7 years, the world started to pay attention. And then of course, during COVID, through ChatGPT, you know, things really, really accelerated in terms of the recognition of the importance of this technology, right? But, you know, and of course, what brings me here today and why I'm so honored to be here is because actually one of the most important engines of innovation and growth, not for NVIDIA, but for the economy and for all the countries that I work with, are startups. I mean, they are the lifeblood of growth and excitement. And as I bounce around the world from Vietnam to Singapore to Australia to India and to Serbia and Saudi Arabia and Canada and all the countries, I mean, never ever do I have a meeting where startups are not a part of the agenda. Always. Because everyone recognizes, you know, the creating the industries of the future that lead to the jobs of the future, that then lead to the next future Steve Jobs of the future, the Da Vinci's of the future. You know, it all starts with this kind of entrepreneurial innovation, whether it's in a university or not. It's super, super important. So from the investors to the startups, and we have this incredible program called Inception. And today we have over 19,000 startups that are part of this Inception program, you know, across the world. And it's interesting because, you know, we have breakdowns and we can look at the data and, you know, there are some really big countries that actually have relatively small startup ecosystems. It's a big problem for them. And then we have some really small countries like Estonia that have huge startup ecosystems. It's shocking. You know, it's so interesting to see the sort of the divergence. So the GDP is not the number one determinant of the size of their AI ecosystem. There are other factors at play, like leadership culture, access to data, regulations, just there's other things that actually turn out here. So some of the smaller countries are doing better per capita than even some of the larger countries, but still very, very important. And you know, look, and AWS and Microsoft and all the tech firms do their best to provide these services, right? You want to innovate, you want to help build, and you want to help grow these startups because they just create so much value. So we offer all sorts of tools and things in there for that. And I promised my people at HQ I would put the barcode up in case anyone wanted to find it. But it's so easy to just go online and type NVIDIA Inception, okay? And then the last thing is that, you know, if you do nothing else, listen into the GDC conference once a year. And you know, that's so important. It's such an amazing event. It's open to the public. You can stream a lot of it online. The keynote in particular is the most watched CEO keynote in the world, 50 million views for Jensen's keynote. It's actually pretty technical because he's an engineer. This is an engineering conference and we are speaking to developers. It's not a CEO keynote per se, even though he's a CEO, but it's a very technical keynote. But he also, you know, kind of just makes incredibly complicated topics very real. So I encourage you to do that. And basically, that's it because I'm out of time. So I'll just thank you for your time, and I hope you have a good day today.